This gaming console looks almost identical to its predecessor, but Nintendo just shocked the world by charging $150 more for it. The Switch 2 costs $450. That's a 50% price increase over the original $300 Switch. So what exactly did Nintendo change in their manufacturing process that justifies this massive price jump? Today we're going inside the most advanced gaming hardware factory on Earth to discover how the Switch 2 is made, and why Nintendo believes this little device is worth nearly $500,000. Trust me, the engineering behind this simple gaming console will blow your mind. The heart of the Switch 2 is this NVIDIA chip, manufactured using cutting-edge 4nm technology. To put that in perspective, these transistors are 25 times smaller than the coronavirus. Creating this chip requires extreme ultraviolet light in a clean room that's 10,000 times cleaner than a hospital operating room. The original Switch used a 12nm chip with 2 billion transistors. This new 4nm chip packs over 15 billion transistors into the same space. That's like fitting the population of Earth twice over into an area smaller than your fingernail. But here's the kicker. This technological leap comes at a cost. While the old chip cost Nintendo about $25 to manufacture, this new 4nm powerhouse cost them $85 per unit. That's more than triple the price for a single component. And we're just getting started. Nintendo surprised everyone by going back to LCD instead of OLED. But this isn't your 2017 LCD technology. The Switch 2 packs a 7.9-inch display with full 1080p resolution. That's 2.25 times more pixels than the original Switch crammed into a screen that's nearly an inch larger. The game changer is HDR10 support, something even the Switch OLED couldn't do. This requires precise backlight control with quantum dot enhancement layers that can display 1 billion colors compared to 16 million on standard LCDs. Manufacturing this level of precision means each panel goes through 15 different calibration stages. Here's why Nintendo made this choice. This advanced LCD cost them $35 per unit compared to $85 for equivalent OLED panels. Nintendo could deliver better gaming features like 120Hz VRR while keeping costs reasonable. Sometimes the smartest engineering isn't about using the fanciest technology. It's about using the right technology. The new Joy-Con controllers look similar, but the engineering inside is revolutionary. Nintendo replaced the sliding rail mechanism with powerful neodymium magnets. These aren't ordinary magnets. Each one requires rare earth elements and must be magnetized to exact specifications. The precision required is surgical. Each magnet must be positioned within 0.1 millimeters. That's thinner than a human hair. The magnetic field strength has to be perfect. Too weak and the Joy-Con falls off, too strong and you can't remove it. Nintendo tests each Joy-Con for 1 million attachment cycles. This magnetic system costs them $35 per Joy-Con pair compared to $12 for the old sliding mechanism. But it completely eliminates the looseness problem that plagued the original Switch. Here's where things get really challenging. The new chip is twice as powerful as the original, but it generates 4 times more heat. Nintendo had to engineer a cooling system that belongs in a gaming laptop, then somehow fit it into a handheld device. The solution is a vapor chamber with copper heat pipes, the same technology used in high-end graphics cards. Liquid inside the chamber evaporates from heat, travels through copper pipes, then condenses back to liquid. It's like having a tiny air conditioning system inside your gaming console. This thermal management system requires surgical precision. The thermal paste must be applied by robots with perfect consistency, and every heat pipe must be pressure tested. This cooling system alone cost Nintendo $25 per unit compared to just $8 for the original Switch's simple heatsink. The assembly process has evolved from 23 quality checkpoints to 47. Every Switch 2 must pass through nearly 50 different testing stations. Robots handle the precision work, but human technicians perform final inspections because some defects can only be caught by trained eyes. Each console takes 45 minutes to assemble compared to 30 minutes for the original Switch. That's 50% more labor time, and in manufacturing, time literally equals money. Any unit that fails even one of the 47 quality checks gets immediately removed from the production line. Nintendo's rejection rate is intentionally high. About 8% of assembled units never make it to store shelves. They'd rather destroy a $300 console during testing than deal with warranty claims later. This quality obsession adds $40 to the manufacturing cost, but it's why Nintendo products last for decades. Let's break down where that $450 actually goes. The materials alone now cost Nintendo $265 per unit, compared to $180 for the original Switch. That's an $85 increase just in components. The 4nm chip, advanced LCD display with HDR10, magnetic Joy-Cons, and sophisticated cooling system. Add in the 50% longer assembly time, 47-step quality control process, and 3 years of R&D with a team of 500 engineers. And you're looking at a total manufacturing cost of around $310 per console. Nintendo's profit margin is actually reasonable. They make about $140 per Switch 2 compared to $120 on the original Switch. The real money comes from games. Nintendo makes $15 to $20 profit on every $70 game sold. The console is just the key to their software kingdom. So is the Switch 2 worth $450? You're not just buying a gaming console. You're buying 3 years of smart engineering decisions, the most advanced mobile chip available, and manufacturing innovations like HDR-capable LCD that delivers features even OLED Switch couldn't achieve. Nintendo didn't just make the Switch 2 more expensive, they made it strategically better. What do you think? Is Nintendo's engineering approach worth the premium price? Let me know in the comments, and subscribe to see how your other favorite tech products are really made.
Here we go!